light, right? I mean, it's stupid. Then why do I even need light? Notice as time goes on for expectation value effects that will change. So if I were to have, I'm going to finish 1.5 and 1.6. D times expectation value of x by dt to integration x curl by curl t psi squared, which is, we know the equation for psi square. So I'm just going to write that section there first. And we know if you were to multiply it from our previous derivative, we know that psi square would be psi conjugate times curl psi by curl t plus curl psi conjugate by curl t times psi. And so curl psi by curl t is simply itemized by that equation there. And then curl psi, so let me just do the general derivation. So general derivation would simply be psi square. So psi square curl by curl t be curl psi by curl t psi conjugate, or first of all psi conjugate curl psi by curl t plus curl psi conjugate by curl t psi. And curl psi by curl t is what? Iota h bar by 2m curl square psi by curl x square minus iota by h bar psi v psi. And if I were to do the conjugate of it, so curl psi conjugate by curl t, which is minus iota h bar by 2m curl square psi by curl, this will be conjugate, plus iota by h bar v psi conjugate. And so then if I apply the same thing again here, so curl by curl t psi square, then I would have x curl by curl t psi square dx, because this is the simple equation of d expectation value of x by dt. So it's simply put is d by dt of expectation value of x, which is d by dt or curl by curl t of the entire equation, which would then be iota h bar by 2m psi conjugate curl psi by curl t plus curl psi conjugate by curl t psi. You're going to put an entire bracket here, dx. This expression can be simplified using integration by parts, that's fine. Well, why would it be minus? I don't understand this part. He said as time goes on, okay, fine. So d expectation value of x by dt is equal to minus iota h bar. Finally, d expectation value of x by dt is equal to minus iota h bar by 2m, that integration there. But why is it minus? I'm confused about this part here. You went from positive to a negative. This section there, how did they get the equation for that part there? how did they get the negative part from positive and derivating the expectation value of x? So dx d by dt of expectation value of x, that's fine. We got the, we take one of the second, so integration of f times g prime prime would be fg bracket. It's not working anymore. Wait. So what did you exactly do? So I made a mistake there. It should be iota h bar by 2m integration of x curl by curl x and psi conjugate curl psi by curl x plus curl psi conjugate by curl x psi. This should be the case. Dx. And so technically I'm literally differentiating this guy here. So I'm only focusing on the derivative part. So only focusing on the, let's close everything, on the derivative bit. So I'm having what? X curl by curl x psi conjugate curl psi by curl x plus curl psi conjugate by curl x psi. Then what did you do? So you did the integration of f times g prime prime, which is fg prime minus integration of f prime g prime. The boundary term, I don't understand the boundary term for step 1. I don't understand the boundary term. I'm presuming that they said limit as x goes to infinite. So limit as x goes to infinite for wave function would be 0, which makes sense, because going from infinite to minus infinite, you'd have it 0. I mean, as it goes to infinite, it's going to shrink. Okay, let's write the general integration. So integration by parts. Integration by parts. So we have integration of f g prime prime dx is equal to fg prime infinite minus integration of f prime g prime dx. So this is the general equation here. Now what? Okay, let's actually move this guy. Okay, it's actually pretty slow. I have to close and then close. Switch off and switch on again. You have to actually learn everything beforehand, which is fun. So we have what? The general integration by parts equation. So general, oh shit, that decreased. Oh my god, that actually decreased. General integration by parts equation, which is integration of f g prime prime would be f g prime from minus infinite plus infinite minus integration of f prime g prime dx. Now this is the boundary term here. This is the boundary term. Yep, it's so this is the boundary term, and this is the remaining integral after moving the derivative. Remaining integral after moving the derivative. So what is our general equation here, which is x times psi conjugate times curl square psi by curl x square. That's the first bit. Because if I look at the equation again, we have integration of x curl by curl x psi conjugate curl psi by curl x plus curl psi conjugate by curl x psi dx. So if you look at this section here, then I'll have x curl psi by curl x and then put a psi conjugate here. So simply I would have x psi conjugate curl square psi by curl x square. And so this equation here correlates to f g prime prime. But which one is f? F is this guy here, g prime prime is this here. So based on this, f is the x psi conjugate, g prime prime is the curl square psi by curl x square. So if I use the same notation, which is fg prime minus infinite plus infinite minus f prime g prime, oh shucks. So f prime g prime dx minus integration of f prime g prime dx. F is what? Now g prime, so which means I would have to integrate it once. So I would have x psi conjugate curl psi by curl x minus infinite plus infinite minus integration of, oh god, curl by curl x of x psi conjugate curls, okay, me 1 minute. So we have what? Bro, I'm so sorry. Fg prime is what? Actually, let me decrease it. Fg prime is what? Fg prime is x psi conjugate curl psi by curl x from minus infinite plus infinite minus integration of curl by curl x of x psi conjugate curl psi by curl x dx. So simply this leads to one whole integration, right? Now here's the key. For physical wave functions, it must vanish. So for the boundary term, only focusing on the boundary term, the physical wave functions must vanish at infinite. So which means limit at x approaches plus minus infinite, psi of x must be 0. And if this is not met, my normalization wouldn't be 1. So typically it would not be normalized. So typically it would not be normalized. Would not be normalized. And so because it goes to 0, and because this wave function goes to 0, x psi conjugate curl squared psi by curl x squared dx would be the same as minus of curl by curl x psi conjugate curl psi by curl x dx. Why? Because as the x value goes to infinite, my overall value approaches 0. And because this is decreasing, and so then eventually, because it's decreasing by the integration of parts, then I can show that d expectation value of x by dt would simply be minus iota h bar by 2m psi conjugate curl psi by curl x minus curl psi conjugate by curl x psi. So this minus is because this overall wave function is actually decreasing, and this threw away the boundary term came in. So threw away the boundary term comes in hand. So I would have the same thing on the right hand side. So the left hand side would be, actually this is not left hand side. No, this is the same one, but after all that, derivation and stuff like that, we end up having minus of curl by curl x psi conjugate curl psi by curl x dx. Or simply I can move this section to the back, so I'll have minus iota h bar by m integration of psi conjugate curl psi by curl x dx. Not yet. Yeah, I'm gonna cook this course. Can't wait to fucking cook this course. Prof, I am so hungry, man. I don't know if I should eat or not eat. They said that what are we able to make of this result? Now that we're talking about the velocity of the expectation value of x, which is not the same thing as the velocity of the particle. Nothing we have seen so far would enable us to calculate the velocity of the particle. It's not even clear what velocity means in quantum mechanics. If the particle doesn't have a deterministic position, neither it doesn't have a well-defined velocity. Yeah, makes sense. Because we don't even know the position of where the particle exists. How are we supposed to find the velocity where the particle lies, right? Like the velocity of that specific particle, we don't even know where the position is. So what did they state actually? They first say that the expectation value of v is equivalent to d by dt of expectation value of x, which indicates that this will not be the actual velocity of the particle, but the velocity that is calculated based on the average position. So technically you're not finding the velocity of the specific particle at a specific point, but you're trying to find the velocity of the entire position, because at the end of the day we don't know exactly where the part. Okay, makes sense. Makes sense. So velocity as the derivative of expectation value so if I have expectation value v is equal to d by dt of expectation value of x, this indicates that this is the velocity of average positions. So keyword here is average positions, because in quantum mechanics we don't know exactly where the position lies. In quantum mechanics we don't know exactly where the position lies. However, instead we know the probability distribution of our average position. So but instead we know the probability distribution of where the particle lies. So which is why we would have to technically derivate the expectation value of x rather than x itself. Instead of velocity, quantum mechanics usually works with momentum. So rather than working with velocity, it works with momentum. So rather than working with velocity, quantum mechanics works with momentum. And what do we know about the general equation of momentum? So general equation of momentum, so we know the general equation of momentum. So if I have P is equal to mv, but I know what V is, right? V here is not V but expectation value of V, which is d by dt expectation value of x, or d expectation value of x by dt. So therefore I would have P is equal to m d expectation value of x by dt. So this means it will be expectation value of P equal to m d expectation value of x by dt. Which is P is equal to m minus iota h bar by m integration of psi conjugate curl psi by curl x dx, where expectation value of P is equal to minus iota h bar integration of psi conjugate curl psi by curl x dx. Okay, what's this? Oh, two expectation values are given. So they're the same thing as the expectation values that we have learned so far. So if I were to look at the expectation value of x, it is simply integration psi conjugate x psi. I just wrote this x separately. And then P would also be the same, psi conjugate, wait, P psi, but P is what? P is what? Minus iota h bar curl by curl x. P is minus iota h bar curl by curl x. And so expectation value of P would be psi conjugate minus iota h bar curl by curl x psi dx. There. Because if the only reason we have curl by curl x is because here P is equal to mv, right? And V has a wave function. P itself has a wave function, V itself has a wave function, which is d expectation value of x by dt. But then d expectation value of x by dt is this here, minus iota h bar integration of psi conjugate curl psi by curl x. So notably, you'd have to add that wave function, but expectation value of p in general does not have a wave function. And so if I were to multiply psi conjugate iota h by curl x of psi, I mean there is psi, once again there is psi, this is the psi. So if I were to write the equation again, psi conjugate minus iota h by curl psi by curl x dx. But we're not writing it like that. Why? If I write the equation again, minus iota h bar curl by curl x psi dx, this and this is, oh shit, this and this will just output psi squared dx minus iota h bar curl by curl x, right? Cool. That's cute. Oh wow, okay. That's cute. Holy shit, man. We're cooking. Look at that. See that? Okay, but what about other quantities? The fact is, all classical dynamical variables can be expressed in terms of position and momentum. So kinetic energy can be formed in half mv square, which is p square upon 2. How? Half mv square. mv square upon 2. Okay, wait, I have an idea. I kind of know how to figure that out. So if I look at the Schrodinger equation, which is minus h bar square upon 2m curl square psi by curl x square is equal to half mv square minus h bar square upon 2m curl square psi by curl x square. How can I express this as p square by 2m? Now this is the kinetic energy part. What was p again? Actually no, how do you go from, how do you derive the kinetic energy to a momentum part? Okay, wait. Position operate is what? So we have our general equation. So T here, which is kinetic energy, and T here is p square by 2m. So position and momentum operator. Momentum operator in quantum POV. So the operator for x would be x, operator for p would be minus iota h bar curl by curl x. So technically we went from minus h bar square curl square by curl x square Wait. Oh, if I have minus h bar square upon 2m curl square by curl x square, this leads to minus 1 over 2m h bar square curl square by curl x square. Or 1 by 2m minus h bar square curl square by curl x square. But since we have minus h bar square, this is simply 1 by 2m minus iota times minus iota, which is iota square. Because wait, iota square is minus 1. So minus iota h bar curl by curl x whole square. And so this then leads to 1 over 2m p square, p whole square. Because this is the general equation for momentum. And then this leads to p square upon 2m. Got it? So you can express the kinetic energy in terms of momentum. So express kinetic energy in respect to momentum. And you can also have the angular momentum. So angular momentum, which is L is equal to R times mv. mv is simply P, which is R times P. This is simply the expectation value of Q with both x and p. So if I have expectation value of x and p, a Q with x and p, then I have integration of psi conjugate. I'm going to put a huge bracket here, Q of x and p psi, which is simply psi conjugate Q of x minus iota h bar curl by curl x psi. Why can't you do an integration by parts directly on the middle of the expression in equation 1.29? Ah. 1.6, 1.7, and 1.8. I'm pretty sure they're gonna finish chapter 1 tomorrow itself, and which means that the due date for the assignment would be on Thursday. I'm 90% sure. Oh, it's just cold. It's not raining. So what does the what is equation 1.29 say? Oh, just write that down. You guys can see, right? This is problem one. Oh crap. So this is problem 1.6. So if I look at the equation again, okay, both of them are using red. I'm actually going to use a different color. I'm going to use probably yellow or orange. Problem 1.6, which was why can't you do integration by parts directly on the middle of the expression in equation 1.29? So you can pull the derivative over onto x and note that curl x by curl t is 0, and that concludes that d expectation value of x by dt is equal to 0. Okay, they gave a little bit of solution there. If I write the equation again, d expectation value of x by dt is equal to integration of x curl by curl t of psi square, which is simply x, curl by curl t. I'm going to put a bracket here. Psi conjugate curl psi by curl x plus curl psi conjugate by curl x psi dx. Now what does d by dt of x mean? We wrote the equation, right? But what in the world is wrong? But if I write this, so x times the curl by curl t of psi square, and writing integration by parts directly would mean curl by curl t of x times psi square dx. And so if I did that, I think they'd eventually find out you'd multiply this part, right? So they would have integration of curl x by curl t psi square dx. But wait, they said that curl x by curl t would be 0. I don't understand. If could you okay, do the wrong derivation for step 2. Because I kind of understood, because curl x by curl t means you're derivating what? You're derivating the no, it doesn't make sense, honestly. Psi square is what? Wait, I'm confused. Wait. No, I understood. This is what they mean by directly moving. So what they would do is like integration of curl by curl t x times psi square. So let's try that actually. Let's say we have curl by curl t of x psi square dx. Let's say we have that. Then I would have curl x by curl t psi square plus x curl by curl t of psi square dx. Oh, this x, like x in general, this is a constant. That is what they would presume. this is, they would presume this, so they would actually presume, this x is a constant variable. Okay, I understood. X curl by curl t of psi square, when I write this, I'm saying that, okay, whatever the derivative I get here, I'm going to multiply it by x to get maybe expectation value. And this writing, okay, I understood. I fully understood. If I have x curl by curl t of psi squared, this means that whatever the wave function I have, I'm going to derivate that. So I'm going to do all the derivations and all that stuff. And whatever the derivation I get, I'm going to multiply this by x. Cool? Meaning that I'm technically finding the expectation value of x. But if I write integration of curl by curl t, x times psi square, this means that I'm writing curl x by curl t psi square plus x times curl by curl t of psi square. But this curl x by curl t, because x itself is a constant value, x is a constant value represented in a form of a variable, writing curl x by curl t will give me 0. So what they would presume is that d expectation value of x by dt is simply 0. And because it gives 0, we are saying what? What are we exactly saying? We're saying that, oh, I know that my average is 0. However, this I know kills everything, because in quantum mechanics I can never say I know. It's probabilistic. I'm going to write it in red. In quantum mechanics, it is always probabilistic, never deterministic, right? So because they'll presume that, oh, it's 0 because x is a constant value represented in a variable, derivating a constant value represented in a variable, I'm going to be like, okay, my dx by dt or curl x by curl t is 0, then I'm saying everything is 0. So I'm saying that d expectation value of x by dt is equal to 0, then I know that the average is 0. I can't even know in the first place. I can't even know. Knowing something means you're violating the law of quantum mechanics. Okay? Let's try 1.7. Calculate dp by dt. Or they gave the answer. P is what again? Okay, this is the Ehrenfest theorem. So problem 1.7. First of all, I'm going to how do you pronounce that? Fuck's sake. Ehrenfest theorem, which is d expectation value of p by dt would be minus curl v by curl x. How do we get that? Now, what is expectation value of p? That is minus iota h bar curl by curl x, and d by dt of minus iota h bar curl by curl x is what? What is the expectation value of p? Is m expectation value of b v, which is m dx by m the expectation value of x by dt. And expectation value of x is simply x curled by psi square. Sorry about that. then I'll simply have m times this section here. Actually, not this section, but the other one, which is no, it's this only. Now, how does this correlate to velocity? Because I know what? I know that expectation value of p is equal to m d expectation value of x by dt, which is simply mv, right? Which is, actually no, let's leave it like that, minus iota h bar psi conjugate curl psi by curl x dx, and then d expectation value of p by dt would mean whatever this equation is, I have to differentiate that, or which means I would have to differentiate m times expectation value of v, and by the Ehrenfest theorem is what? Minus curl v by curl x. Thing is, what I want to do is, like, if I write curl by curl t of m d expectation value of x by dt, because m cancels out, so I'm having curl by curl t of m. Actually no, m goes first. If I have m it should be del v. If let's try m del v. If I have m curl by curl t of del v plus curl m by curl t curl m by curl t expectation value of v. And it doesn't work like that. Surely there is a way. What did they do? Would they do 1.7 as an example? Because I know I'm pretty sure they're going to finish this tomorrow itself. Like 90% certain they're going to finish it tomorrow itself. I can pretty much say they're going to finish it tomorrow itself. Yeah, I can pretty much say that they're going to finish it tomorrow itself. Yeah, highly likely that they're going to finish it tomorrow itself. pretty slow. Expectation value of p. I know what the expectation value of p is. So expectation value of p, value of p. So p would be psi conjugate x of t, operator p, and psi of x and t, which is simply psi conjugate. I'm not writing the x and t for now. Minus iota h bar curl by curl x psi. So d by dt of expectation value of p would mean d by dt of this entire thing minus iota h bar curl by curl x psi wait, what's that? Wait, what? D by dt of expectation value of p is d by dt psi conjugate times iota h bar curl x psi. I don't understand step 2. Wait, how did you get step 2? I don't understand step 2. Now I understood this section here. Oh yeah, it is pretty slow, I'm gonna be very honest. Anyways. So expectation value of p is what? Bro, how do you get that minus iota? Yeah, how do you get that part? What I'm confused is how do you get this here? Yeah, bro, after finishing this and uncertainty principle, I'll finish off the one of the assignments, then I'm going to see like full on. Yeah, anyways, Let's do the uncertainty principle for now. Imagine you're holding one end of a very long rope and you generate a wave by shaking it up and down. Oh, okay. Yeah, we know the general equation for expectation value. So what they said was, I'm gonna keep that equation. P is what? Minus iota h bar curl by curl x. That de Broglie we've been looking fine. And P psi would be minus iota h bar curl by curl x psi. So isn't that simply minus iota h bar curl psi by curl x? And then from there on, you calculated to have d by dt of expectation value of p, which is d by dt of psi conjugate minus iota h bar curl psi by curl x dx. And because you have a psi conjugate and then psi and all that stuff, then you're simply going to have d by dt of expectation value of p, which is d by dt curl psi conjugate by curl t minus iota h bar curl psi by curl x plus psi conjugate minus iota h bar curl psi by curl x dx. Brother, I have no fucking clue. No fucking clue. Anyways, that's it for 1.5. God, man. Horrible. Let me write something first. Section 1.6. I'm going to finish it today itself. Is the uncertainty principle. The uncertainty principle.